So what you see there is the investigation we had done. We're just going to go over the answers real quick. We need to make sure that we understand how we got everything we got on the investigation before we go further. Problem number one, a sign on the right triangle is opposite over hypotenuse. On the unit circle, it's y. The reciprocal is cosecant. So cosecant can be written as hypotenuse over opposite or 1 over y. Cosine is adjacent over hypotenuse. On the unit circle, it's x. The reciprocal is the secant. So it's secant can be written as hypotenuse over adjacent or 1 over x. Tangent on the right triangle is opposite over adjacent. On the unit circle, you would have to do y over x. The reciprocal is the cotangent. Cotangent is adjacent over opposite or y over x. Now, if we want to write the reciprocals using only trig functions, we know that the sine of theta is 1 over the cosecant of theta, and I should write the thetas there. So cosecant is 1 over the sine, and cosine can be written as 1 over secant. Secant can be written as 1 over cosine. Tangent can be written as 1 over cotangent. Cotangent can be written as 1 over tangent. So using that information, I wanted to really make sure you were getting the problems down at the bottom, because you're going to have to be able to do those problems. So if sine is 2/5, since we know that cosecant is the reciprocal, it's really great because the cosecant then is 5 over 2. For B, since the tangent and cotangent are reciprocals, if tangent is -4/3, then the cotangent is -3/4. For C, if the secant is 6, you can just put that over 1. So you always want 2 pieces when finding a reciprocal, and that's why the cosine would be 1/6. Now, the interesting part about D is the multiplication of any 2 reciprocals is always 1, and that even applies to our trig functions. So if this one was 1/2, then this one would be 2. 1/2 times 2 is indeed 1. So every single set of reciprocals on this page, if you were to multiply them, you're going to get 1. So sine times cosecant is 1. Cosine times secant can be reduced down to 1. Tangent times cotangent is reduced to 1, as long as you're dealing with the same angle. So the answer there is 1. Any questions on that first page? Okay, let's go to the next page. The Pythagorean theorem is that the sum of the squares of the legs is equal to the square of the hypotenuse. So the triangle that's on the page there, it would be x squared plus y squared equals 1. On the unit circle, the hypotenuse is our radius. It's always 1. It's called a unit circle because the radius is 1 unit. The x is the cosine, the y is the sine. So if we replace x and y with its trig function, we get cosine squared plus sine squared equals 1. Now, it's very often written sine squared plus cosine squared equals 1. I don't care which way you write it. Okay. If we divide through by sine squared, we get cotangent squared plus 1 equals cosecant squared. So that's a different identity using different trig functions. If we divide through by cosine squared, we get 1 plus tangent squared equals secant squared. Now, these do not apply if the squareds are not there. The Pythagorean identity is just like the Pythagorean theorem. On the Pythagorean theorem, we don't say a plus b equals c. It's a squared plus b squared equals c squared. So the Pythagorean identities only give a relationship between squared things. So the table is what you see here. Cosine squared plus sine squared equals 1. Cotangent squared plus 1 equals cosecant squared. 1 plus tangent squared equals secant squared. Now let's talk about number 8. This here is the same as the cosine squared. And the reason that is an equation is manipulable, if that's a word. You can do things to that equation. If we took the sine squared and brought it to the other side, it would be saying on the page, cosine squared is 1 minus sine squared. So then you get 1 over cosine times cosine squared. We have one of them that can cancel out with one of them. So our final answer, we have 1 cosine remaining. So that is number 8. Let's talk about even and odd. We had done even and odd functions back in college algebra in the first semester, our pre-calc stuff. An even function has y-axis symmetry. An odd function has origin symmetry, just like our parabola and our cube function. Algebraically, if you stick in negative x for a even function, it should go right back to its original form. If you stick in negative x to an odd function, it should be the opposite of its original form. So every y-axis symmetric function, that will happen. Now, our trig functions are kind of interesting. Every single one of them are odd and have origin symmetry. Now, we're talking about the parent before they've been messed up, except for 2 of them. The only 2 that you should have written as even that can be folded across the y-axis is our cosine and its reciprocal, our secant. So if you look at the chart, the cosine and the secant are the only ones when we stick a negative in, it doesn't do diddly squat, okay? The other ones have origin symmetry. They are odd, so that when you stick a negative in, the negative can come out in front, and that is going to be a technique we use to help us, okay? Now, there was a little typo in number 12, so if you didn't understand how it was written, I apologize. Let this parenthesis right here, let's put it right there. So that's what I wanted it to say. And I'm sorry, it didn't look that way. Okay, so let's look at number 12 written the way that I have it up there. You have to first discover, where do I move the negative if it's inside that type of function? A cosine and a secant are both even functions. So the negative just disappears for a cosine and a secant. If it were any other function, you could write the negative out in front. But a cosine and a secant, they're even functions, so a negative doesn't do anything. You can just kind of erase it. And we know that a cosine and a secant are reciprocals, so our final answer is 1. So that's your even and odd. The answer to that was 1. 13, tangent is opposite over adjacent, y over x, sine over cosine. So then if you flip it, cotangent would be cosine over sine, and that's what I wanted in the table here. So if you could put that in your table, tangent is sine over cosine, cotangent is cosine over sine. Now think about everything that we know we built from stuff we already know from chapter 7. So these are not new facts, they're just facts you might not have known existed, okay? And then I would like to now answer problem 14. It says if the secant is 5 over 4 and the tangent is 3 over 4, then find the cosine and sine. Now I will tell you, there was a student in one of my classes that drew a triangle and did all the triangle stuff. Totally legitimate, that works. But what we're trying to focus on in chapter 9 is the algebraic components of this. We don't want to have to draw a triangle. It's not wrong to, but we don't want to have to. So let me show you a suggestion. Which one of these facts leads us very clearly to one of the things we're looking for? One of these facts helps us find one of these in a blink of an eye. Which one? The secant tells us what? It is the reciprocal of our cosine. So I immediately know that the cosine is the reciprocal, Mrs. Hott, 4 over 5. Okay, so that one's done. Bam, great. But now we have to figure out what can tell us the sine. And I'm going to show you 2 different things that are both legitimate ways to do the problem. So you might have done it one way and another person might have done it, but it's a totally legit. Again, you could have drawn a triangle, but we're trying to move past that. We know that the tangent is sine over cosine. Now that we know the cosine, let's just fill those values in. The tangent is 3/4. I don't know the sine. The cosine is 4/5. I can use cross multiplication so that the sine is 3/4 times 4/5. So a tangent times a cosine will always be a sine because of the fact that tangent is sine over cosine. So the 4's cancel. The sine is 3/5. If you were to build your triangle, guess what? That's exactly what you would have got. Exactly what you would have gotten. Okay. Your opposite would have been 3. Your hypotenuse would have been 5. You would have gotten 3/5. Okay, so that's one way, totally legit. I want to show you a different way. We also know the relationship that cosine squared plus sine squared is equal to 1. That's another way to do the problem. Cosine we found was 4/5. 4/5 squared is 16 over 25. 1 is 25 over 25. 16 from 25 is 9. Sine squared is 9 over 25. So if you take the square root of 9, you get 3. If you take the square root of 25, you get 5. That's another way to get to the same place. So if you use the Pythagorean identity, which is a fact that is always true about our trig functions, and someone else used your tangent quotient identity, if someone built a triangle, 3 very legitimate ways to find the answer. I really don't care which way you go about the process. So if you want to do it one way and you want to do it a different way, yay. As long as you get 3/5 when it's all said and done, you have found the sine that goes with that particular angle. Does that make sense? If you want a denominator of 25, just make it 25 over 25. That's the simplest way to do that. Okay, so this should be done. Turn it in. Make sure you turn it in. And then I will tell you there's a bonus opportunity. The old 9-1A notes are still out there. If you do them, and you'll get some bonus points. If you also do the 9-1A homework that's out there in the chapter 9 notes, I'll give you bonus points for either or both. Okay, so you'll get extra if you do the whole darn thing. So that is a bonus opportunity if you want to take it. Okay, so turn that in at this time. And now let's talk about what you have to have memorized for the quiz on Monday. So for Monday, I am going to hand you this very sheet. And I'm going to say fill them in real quick. Okay, that's what Monday's quiz is all about. Okay, so let's just practice one more time. And then there's some bonus that you can get in here too. Okay, so let's start with the top, our reciprocal identities. Sine is 1 over the cosecant. Cosecant is 1 over the sine. Cosine is 1 over the secant. Secant is 1 over the cosine. Tangent is 1 over the cotangent. Cotangent is 1 over the tangent. Okay. Now, what there are on every single one of these, I forgot to write them on the others, but there are some bonus that I'm going to put over here. If you do a rewrite to that, and you tell me what the rewrite is correctly, I'm going to give you some bonus points. So the rewrite here would be that sine times cosecant is equal to 1. Cosine times secant is equal to 1. And tangent times cotangent is equal to 1. There's not really, let's erase that. Okay, there's just 3 rewrites for that particular one. So if you cross multiply, sine times cosecant is equal to 1. Cosine times secant is equal to 1, and tangent times cotangent equals to 1. Get yourself some bonus points by giving me those 3 rewrites for our reciprocal. So the original 6 facts actually leads us to 3 more. Okay, so those original 6 facts actually leads us to 3 more, which is always great, you know? Okay, those are little bonus facts. Pythagorean identities that you have to have memorized. Cosine squared plus sine squared is equal to 1. If you do not put the squareds, I will mark it wrong. It is not correct. The Pythagorean identity is based upon the Pythagorean theorem, a squared plus b squared equals c squared. Next, cotangent squared plus 1 equals cosecant squared. And then finally, 1 plus tangent squared equals secant squared. Okay. Now, what's interesting is our Pythagoreans each have 2 distinct bonuses that we can get for those. I don't care what order you put these bonuses down, but if we solve for the cosine squared by bringing the sine squared to the other side, it would be 1 minus the sine squared. So cosine squared is always equal to 1 minus the sine squared. Think about if you're solving for the leg on a right triangle, you have to subtract the other leg from the hypotenuse. So that's why it's a subtraction now. Now let's get our sine squared by itself. If we solve for sine squared, we got to take the cosine squared to the other side. So it's going to be that the sine squared is 1 minus the cosine squared. So if you can rearrange your Pythagorean identities for each of these, that's possibly 6 items you can get bonus on. Now let's do the same thing for our second Pythagorean. If we solve for the cotangent squared, we have to subtract the 1 from the other side. So cotangent squared is always cosecant squared minus 1. If we solve for 1, we have to move the cotangent squared this time. So it's cosecant squared minus cotangent squared. So you get 2 for that one. And then we're going to do a similar technique for our last one, our tangent squared and secant squared one. If we get the tangent squared alone, it's secant squared minus 1. If we get the 1 alone, it's secant squared minus tangent squared. So the Pythagoreans are very powerful. The sine squared plus cosine squared equals 1 gives us the other 3, or the other 2. And then you get kind of 6 extra bonuses from that even. So you really, it's just a powerful relationship between our trig functions that you may not have known before. Okay. For the even and odd section, if I were the person doing this, I would immediately jump to the cosine and the secant being even. I would immediately jump to the cosine and the secant being even. So that means they have y-axis symmetry. And you don't have to write the whole word y-axis symmetry. Just write y-axis. I know what you're talking about. So they are the only ones that the negative can just disappear. It doesn't do anything. So it can just be canceled out. All of the other ones are odd. So let's put odd for all of those. And then just write origin there for those ones, for the type of symmetry. And then for those, a negative that's on the inside can pop to the front. So those ones, your negative should pop to the front. So that is the even and odd section. There's no real bonus there, sorry. So that is your even and odd section. And then finally, for tangent and cotangent, so tangent would be sine over cosine. Cotangent would be cosine over sine. There are some bonus opportunities there. Those opportunities happen just by cross multiplying whatever your denominator is to the other side. So I can say that a tangent times a cosine is always a sine, or a cotangent times a sine is always a cosine. So your identities are super important because they are going to allow us to do algebra to our values, because we will know relationships between all of our trig functions. Just like our unit circle, which for some of you still might not be in your brain, please take a look at that again. But that's something we have to have memorized. And then all of these relationships we have to have memorized. I don't have you memorize things lightly. I have you memorize them if it's essential that you just know those off the top of your head. So please at this time, turn this in, study this, quiz on Monday.